All right, well, hello, sixth graders. We are looking right now at our video for Friday, April 30. And so we're continuing with inequalities. Now, you'll remember yesterday on Thursday, we were graphing inequalities. And we're going to continue with that today a little bit. But we're also going to be looking at inequalities in a little different sense as well. Let me get my marker organized there. So you have several sets of directions that you're going to be working with today from Big Ideas book, pages 333, 334. To start with, the first set of directions says to write the word sentence as an inequality. So when I look at this first example, it says a number z is less than 11. So remember my inequalities. We could have less than, we could have greater than, we can have less than or equal to, or we could have greater than and equal to. Any one of these four inequalities will work. So, a number z is less than 11. So we're going to start with z, but it says less than. Now this is the less than inequality. So we're going to have z is less than 11. And that's going to be our answer. Not hard. The second one says a number b is more than 8, so more than. We're going to start with b. That's our inequality for more than. We often refer to it as greater than, but more than and greater than means the same thing. So b is more than 8. The next one is 2 plus a number z is no more than 12. 2 plus a number z is no more than 12. Well, first of all, 2 plus a number z. So we want 2 plus z. It says is no more than. Well, it can equal 12, but it can't be more than 12. That's what no more than 12 means. If it is 12, it's okay, but it can't be more than 12. So I would have to use this inequality. Less than or equal to. My answer can be less than 12, but it can also be 12, is what no more than 12 means. So we look at our last one. A number x divided by 4 is at most 62. Well, first things first, x divided by 4. We have to know, sixth grade, that that's going to be a fraction. We got to write that as a fraction. X divided by 4 is at most 62. It means it can be, 62, but at the most, it's going to be 62. So once again, I'm going to use my less than or greater than, listen to me, less than or equal to inequality, because it can be 62, but it's at most 62. Which means that's the biggest that it can possibly be. So when it says write the inequalities, on this section, you're going to be writing something like all of those. All right? Let's talk about the second part. Tell whether the given inequality is a solution of. Tell whether the given value is a solution of the inequality. All right, so it might give you something that looks like this. X minus 1 is less than or equal to 8, and then it's going to say x equals 7. Well, so this is what I do. First of all, I'm going to take 7 and I'm going to plug it in for x. And it's going to say, well, 7 minus 1 is less than or equal to 8. Well, let's see if that's true. Well, I know that 7 minus 1 is 6. So if I plug in the 7 for x and I do 7 minus 1, I get 6. 6 is less than 8. So this one would have to be a yes because it works. Because I would get 6 if I did 7 minus 1. And 6 is indeed less than or equal to 8. All right, let's look at another one. Let's say 3x is greater than 8. X equals 3. Well, 3x is greater than 8. X is equal to 3. So once again, I'm going to plug in 3 to my equation. 3x, we know that this means multiplication. So this is 3 times 3, since x equals 3. Well, 3 times 3 equals 9. and 9 is greater than 8. So when I take my 3 for x and I plug it in, I do 3 times 3 and I get 9. 9 is greater than 8. So I'm going to get a yes there. Very good. All right, let's look at one more, and then we'll move on. All right, let's say that I've got x plus 2.5 is less than 4.3, and we're going to say that x equals 1.8. All right, so x plus 2.5 is less than 4.3, and x equals 1.8. So if I'm going to take 1.8 and plug it in for x, I'm going to be doing 1.8 plus 2.5. So I'm going to come over here, and I'm just going to plug in my 1.8 there. I'm going to go ahead and add them. 5 plus 8 is 13. Put the 3 down, carry the 1, drop my decimal. 1 plus 2 is 3, plus 1 is 4. Interesting, it equals 4.3. So I end up with 4.3 is less than 4.3. Well, that is not true. 4.3 is equal to 4.3. 4.3 is not less than 4.3. So this one here would be a big no there in example 3. Okay, so now let's clear some space. All right, we'll go ahead and use this same board here. All right, and what it wants you to do is it wants you to write an inequality and a word sentence that represent the graph. All right, so here's a graph. All right, going to get something that looks like this. All right, we're going to put a 2. We're going to have an unshaded circle. It's going to go left, 1, 0, -1, -2. So there's our graph. Okay? All I know here is that whatever it is less than 2. Because it's going left, which means it's less than, and it can't equal 2 because it's an unshaded circle. So this would become x is less than 2. That's the inequality. I want to make that very clear. But it tells you you also need to write a word sentence. Well, so for a word sentence, I would say a number x is less than, or let's say is fewer than, we can use some different words, some synonyms, is fewer than 2. All right, let's look at another graph. This time let's have a shaded circle. Let's have a shaded circle over -8, -7, -6, -5, -4. I'm going to go to the right. Remember, as my negative numbers get bigger and I get closer to 0, my digits actually get smaller. So when I look at an inequality, first of all, I know my number is getting bigger. So it's going to be greater than. But my circle is shaded. So it's going to have to be x is greater than or equal to -8. But now I need to write my word sentence, okay? Where I might just say a number x is at least -8, okay? At least -8 means it can be -8. But -8 is the least that it can possibly be. If it's not -8, then it has to be something that's bigger than -8, which is what is displayed right there in that graph. All right? Last part. And this is just a review of what we did yesterday. And I want to do a couple specific examples to kind of answer some questions that there may be. And it's going to tell you to graph the inequality on a number line. Okay? So, yesterday we were pretty much working with whole numbers. All right? So, let's say, for example, that I'm going to do x is greater than 1.6. All right? So, first of all, I know that my graph has to start with 1.6. I know that it has to be unshaded because x cannot equal 1.6. X is greater than 1.6. I know it's also saying that x is greater, so my line is going to go to the right. Now, with decimals, I have a couple different options. If I wanted to, okay, I could say, well, 1.7, 1.8, 1.9, 2.0. That would be fine. I could also, from 1.6, if I wanted to, just do 2.6, 3.6, 4.6, 5.6. I'm guessing that there's probably some questions about how we handle that with decimals and fractions, so that's why I'm kind of doing these examples. Let's do one more. Let's say that, I don't know, we're going to say that 7 and a half, okay, is less than or equal to x. Now here's something that's interesting, because we have not done fractions yet. So, well, technically this is a mixed number, but it's incorporated with fractions. And my variable is over here. I'm putting my variable over here very purposely because I want to point something out to you. I want to make it very clear to you that this is not an arrow that is pointing what direction the graph is supposed to go. Every year, I have been doing this sixth grade for many years. I have been teaching this longer than you have been alive. And every year we have students who automatically assume that whatever way this arrow is pointing, that's the way the graph is supposed to go. That is false. Fake news, call it whatever you want. That is not the rule. What determines what direction the graph goes is based on what side of the inequality the variable is on. Here the variable is on the right. It doesn't mean the line is going right, but here it's on the right. It is on the bigger side of the equation. If you envision like a Pac-Man or envision this like an alligator that wants to eat something, the mouth is always open to the bigger side. It wants what's bigger. And in this case, x is equal to or bigger than 7.5. So this is bigger. So it wants to eat this side. So since it's on the bigger side, my line is going to be going to the right. Okay? That's what that means. So we know that my graph is going to start at 7.5 because that's what it says. It also says that 7.5 is less than or equal to, so it's got to be a shaded circle. But this, not only does this say that 7.5 is less than or equal to x, we can also read this backwards and think of it about saying, well, x is greater than or equal to 7.5. So the x is greater, it's on the bigger side, which means the inequality needs to go to the right. Now, in this situation, 7.5, you need to be very careful with your fractions because you need to remember, oh, well, I might put 7 and 1 over 3. Well, that's not true because 1/3 is less than 1/2. You'd be putting the wrong numbers. So my recommendation in a situation like this with 7.5 would be to stick with the half that's there. Go 8.5, 9.5, 10.5, 11.5, and that would be your graph. All right, sixth grade, I'll be available to help you with this assignment on Thursday, April the 30th. We'll talk to you soon. Bye-bye.